So now we are going to do good day. This is Dr. Masalila. We are continuing with our dynamics. Now we are going to do the third law of Newton. What did Newton say on the third law? Newton told us about something which is interesting. So third law is in other words, it just states that when you have an object 1 and object 2, if they have equal forces which are acting oppositely, actually you can see here that this force is acting towards this direction and this force is acting towards this direction, and if these forces are the same that and are acting in opposite direction, that is the third law of motion. So distinguish between forces exerted on the object and forces exerted by the object. Motion of the body depends on the forces exerted on the body. Forces exerted on the body. No acceleration because gravitational force of the body and F2 are opposite and are equal in magnitude. So in third law of motion, there's going to be no acceleration. What is mass? What is weight? A measure of the amount of matter in an object is mass. Mass does not depend on a place where the body is. Therefore, weight is the magnitude of the gravitational force exerted by the earth. Depends on the place where the body it is. The force exerted at the surface of the body is called the normal reaction. The force exerted on the surface of the body is called the normal reaction. It is N or R. Always act up. You see, you can see that this is a body, this is our body. This body is on top of this surface, so it's going to exert such a force N going there. It's going to be N. This force is going to be mg because it goes up, goes down. And when N and mg are equal, N is equal to mg, there's no acceleration and there's no movement because the reaction force is also the same. The reaction force is the same as the force, the other force there. N is always perpendicular to the surface. It means it acts at 90 degrees always. Now, let us do the following example. Don't be scared. The figure shows a mass M hanging from 3 wires. The mass M is hanging on 3 wires. Determine the T1 and T2. Identify all the forces. Identify all the forces which are acting at a point and the respective accelerations. Let us identify the forces which are acting. Let's assume these are wire. These are strings. String 1 and string 2. We have 3 forces which are acting. Because there's a mass hanging on a wire. Example. Take example ka mogala. Let me say ngwane kana bogeletse mogala go khoneng ye, bogeletse mogala go khoneng ye di khona ye, selo se se lepella mo mogala wa gago yana. Wa bona sa lepella mo mogala wa gago yana. Because that thing is stationary. That thing is not moving. The mass is going to exert an mg force going downwards. T1 is a force where I can make point A, the point B. Gore mogala wa rona yo o itshwele go point A. Go na le force e yang go e itshweletseng go point A. Gore mogala wa rona yo o itshwele go point B. Go na le force e e itshweletse kae go point B. So, I would draw a free body diagram. You just show a force that no, I have mg. Dot yeah. I have T1. I have T2. This is what you call a free body diagram. This is what you call a free body diagram. Now, let us resolve the forces. when we started dynamics, we said that we had mogala yo wa point A, mogala wa point B. T1 force is a vector, meaning we have to resolve the vectors. The first step is to identify the vectors. The second step is to resolve the vector. T1 is a vector, meaning that ya go acta yana ina le the x part, ibe acta yana ina le the y part. Like yone ha ka ke ya acta ela I acta sonanyana, like because as a scalar. T2 lone ya go acta in the x part vector, ibe ta acta where ibe acta in the y part, ibe acta in the y part. So that is where we resolve the vectors. So according to vectors, you know how to resolve this, you know how to resolve this. According to vector, you know how to resolve this, you know how to resolve this. So our equation 1, we are going to say, now we are going to take forces which are acting in the x-axis, and they say we have T2 is acting in the x-axis, T2 is acting minus T1 is going to give us 0 acceleration. Again, we say that this force is the same as this force, so they are going to give us what? 0 acceleration. Then we go further to what? We go further to the forces which are acting in the what? In the horizontal. Forces which are acting in the horizontal, we have this one, T2 plus T2 minus this force, because it's opposite, they give us 0 acceleration, because what did we say? Acceleration here is constant. Acceleration there is what? Is constant. So now we now make this subject of the formula, then we continue, then we finish.